It's very important to have a suspension which is distributing the load on the tyre in the correct way to get the most out of it.
Suspension design requires a team working between all departments of Formula One car.
If you get your suspension in the right position, then there can be a lot of performance. So if you put it in the wrong position, that it can limit your potential throughout the year.
So the suspension of a Formula One is made of three different areas. We've got the inboard suspension, where we normally fit dampers, spring and anti-roll bar. We've got the external members, wishbones, like this one. They're made of high-strength composite fibers and are taking significant loads. And we've got the outboard parts, namely upright, like the one you've seen. We apply a lot of creative thinking to bring performance to the car by innovation.
From aerodynamic point of view, we put down a concept, we were verifying in CFD, then we sit together with other colleagues to find the best compromise to make the car faster.
The aerodynamics in the car is extremely sensitive to the attitude of the car, and the attitude is determined by the suspension.
The challenge for us is to have the suspension in a position and a shape that maximises the aerodynamic performance. And this is often traded off with the mechanical aspects of the suspension. So we require very good communication with Faenza.
The project of the suspension starts in the machine shop department, where we create the molds. Afterwards, they go to the composite materials department for the lamination. We have 2 phases of lamination and 2 phases of mechanical manufacturing. After the second mechanical stage, the part undergoes some quality checks and then is glued together with the other metallic components. Afterwards, it'll be checked again and assembled in the car. Once it's been laminated, the part is put into a plastic bag and placed for cooking. The part goes back to the machine shop for the mechanical manufacturing. This is a very important phase because it must be very precise.
Now we go for an ultimate load test. That means we will fail, we will have a complete failure of the component. We will apply a tensile load, and look for that, we will have some failure somewhere in the component. I think you can hear noises. Carbon fiber are having troubles. We had a crack in this part of the component. Safety factor is bigger than 1.5, so we can say the car can run safely.
The good challenge in terms of quality control for this kind of part is to be in the process, in order to guarantee that the manufacturing of the front lever is really done following what the design is requiring. Everything must be certificate, because we need to be sure that the process is fine.
And finally test it the best way we can. That's normally here statically, or perhaps on a Friday at a race, until we're 100% happy it's working correctly, and only then will it hit the car for a race weekend. So it's a long process.
Here you can see the suspension installed on the car. Here we have the top wishbone, bottom wishbone, push rod and track rod makes the wheels turn. Fully installed on the car, and this car is about to go racing, so this is what it looks like when it's finished.